Your Excellency, Minister Bawardi, Excellencies, Ministers, distinguished guests, generals, ladies and gentlemen, assalamu alaikum. And thank you so much for this opportunity to represent Lockheed Martin here at this important forum. And on behalf of Lockheed, I must say it's a tremendous honor to be able to work with the Ministry of Defense, with Tawazun and Edge and others on this important area of advancing important technologies going into the future. You know, before I was with Lockheed Martin, I was a soldier in the United States Army for 36 years, and I served 6 years in Afghanistan, and it was my honor to serve alongside UAE armed forces in that conflict. And I want to express the gratitude and respect that all American and NATO soldiers hold for the UAE and its armed forces. Thank you for your service alongside of us. I also want to convey what Lockheed is doing today in this area. So this topic is extremely timely. It's what our company is all about. Over 100,000 employees, most of whom are engineers and scientists. So working on these exact issues that we're discussing today. So very, very important. And it's an honor for Lockheed to be partnered closely with the Ministry of Defense in not only in ensuring the security and defense of UAE today, but also going into the future. There are many considerations when it comes to technology, and we'll hear from an expert panel here in a few minutes about it. We're going to look at the emerging technologies in this area and how those impact. Obviously, artificial intelligence is at the center of that, but there are many other technologies as well that are relevant. So our panel members will discuss what those technologies are. We'll also talk about the application of those technologies in various domains, space, aerospace, land, sea, and air, but also inside national systems as well. And then finally, the ethics of the employment of these technologies. Ethics has come up a number of times during the panel so far, and we'll explore that more as well. And to that end, I just want to share a vignette about the use of unmanned technologies in the last 20 years. We heard about that on some of the previous panels. But let me share with you a typical mission profile on the use of unmanned technologies and how ethics and other considerations apply. So here in this region, for example, if going after a particular target in a remote area, a typical mission profile would involve an unmanned platform takes off from an airfield somewhere in the region. When it does so, it's controlled by a pilot who's sitting in the United States, maybe at Nellis Air Force Base. This linkage is dependent upon satellite technology, GPS technology, and other technologies. It flies to the area where the target is located. It has a limited loiter time because of the limitations of the technology and keeping this system aloft. It is then controlled. The command and control, though, comes from another location, a command center somewhere in the region, maybe probably in the country where the asset is being employed. And in that command center is sitting a commander, and somewhere nearby is a lawyer. And the lawyer is looking after the appropriate employment of the system. So for example, if you're going after a particular target, you need positive identification of who that is. So many other systems are involved to fuse the intelligence necessary to ensure that the target is the correct target. You then, of course, have the actual firing of a weapon at a target. Okay, this also involves humans in the loop. What is the weapon you're firing? What is the blast radius? Are there any innocent civilians in that area? If there are, do you wait? Do you wait for a better shot when you're not going to endanger innocent lives? So all of these considerations have been built into the application of unmanned systems as we have used them in the last 20 years. That system that I outlined, though, as you look at the new technologies, is at risk. You know, it was optimized for ethical decision-making and application. But if you were faced with a swarm of adversaries, would that system work? Probably not. If you were faced with an adversary that could disrupt your GPS, or disrupt your satellite linkage or disrupt your command and control linkage, would that system work as well? No. And then if you had not adapted your system and the swarm got through your defenses, now your own population is at risk. So is that ethical? Not really. So there's many angles to this conversation about ethical use of unmanned systems and new technologies. And we're fortunate to have a great panel with us today to discuss those efforts. And so I'd like to introduce them now and ask them to come up. First, we have Dr. Nenad Miloradovic. Dr. Miloradovic is the Assistant Minister of Defense for Material Resources from the Republic of Serbia. He's an academic, an engineer, and a seasoned defense industry expert with a background in system development. Please welcome Dr. Miloradovic. Next, we have Commodore Michael Brasseur. Commodore Brasseur is the head of U.S. Navy's Task Force number 59 in Bahrain. He is working to embed artificial intelligence and unmanned systems into fleet operations to improve their safety and security in the Gulf. Thanks, Mike. Next, we have Professor Usama Hatib from Stanford University. He's the director of the Stanford Robotic Lab. He specializes in human-centered robotics and is the president of the International Federation of Robotics Research. Welcome, Professor. And joining us virtually, Professor Lakmal Seneviratne. He's the director of the Khalifa University Center for Autonomous Robotic Systems here in the UAE. He is an expert on robotics and automation and has over 400 peer-reviewed publications in this area. Well, welcome all the panel members, and each of you bring different areas of expertise to this panel, an important panel. And for our first question, we want to discuss which specific areas of technology, in addition to artificial intelligence, which obviously is central to all of this, but what additional areas of technological development are critical as we look at the future of this? And Professor Miloradovic?
Not yet, Professor.
Please.
Working on it. Thank
you.
Go
ahead.
So my take on this is maybe a bit conservative, because you may interpret that as a defense mechanism from an old engineer coming from a previous age of engineering of the last century, and might be pointing out that not all of that is so unheard of and so new here. But let me put it like this: my take on this is, let's say, the robotic armored systems, which we will be mainly dealing with in the future to come in our militaries, can be conceptually divided in two different categories. A first one, which is very popular now, swarming ones, which will be primarily tasked to defeat the opposition with their sheer numbers and their coordinated behavior, not with their individual strengths. They will be the true babies of the fourth industrial revolution technological surge, and they will be based on the, as we know, micro-sensing, the very robust communication to take control of all of this data coming in and out, very heavy on computing. AI, of course, without them, it won't happen. And of course, they will be built by novel technologies with the aim to build them cheaply. Mm-hmm. Now, there is a totally different animal, if I would say that, the different type of robotic combat systems which are built or will be built to mimic a human warrior, mm-hmm. and to build to mimic the human fighting platform, and to be blended into human warfare formations. Mm-hmm. Now, those are much more valuable. They will be individually much more potential. This is what we require from them, and we will want to guard them, and most of the currently ongoing technologies which are there to support the manned platforms will still apply. So let's talk about the, for example, ground platforms. We want our combat robots to be with the quality camouflage, with the new electric skin that will spoof the AI-enabled opponent, which is dealing with the imaging processing. Then we will, of course, we'll need to deal with their signature management. We'll need them to be protected with the passive and active armors. For example, we in Serbia, we have built our own first robotic armor, which is a robotic combat vehicle, which is armored on the outside. The new ones are going to come with a new generation of armors. We need to imply the new power packs right now, preferably electrical or combined. Right now, we need to work on that because the current novelties are not. For example, if you want to build a tank-sized vehicle with the fuel cells, it will have a power pack which is 2 times the size of a tank. So we need to work on it. And yes, of course, we want to apply all of these new technologies, wheel hubs, which will bring variable geometry vehicles, which will go anywhere, climb the rubbles of the future, disturb the urban areas, and lethality. This is my crucial point. Now, for the aerial vehicles, we have seen dedicated weapon sets which have been developed, by the way, in a process winning some wars recently. But for the ground combat vehicles, and of course we want them to be extremely lethal, we want them to defeat the opponents and to outshoot the opponents' loyal wingmen and the robotic brothers in arms. But typically in the ground forces, they are now equipped with the turn of the century infantry-style weapons, machine guns and rocket launchers and so on and so forth. One purpose was logistics. But then there comes a point when probably you, sir, from the infantry, you will probably know, but I assume not very many people from the audience would take for example, what it takes to reload the belt-fed machine gun. Right. So you will probably need a 2-handed robot to do that, and it's very difficult to do this in the field. And so let's say our golden army, which will go there of our robots, will very soon have to come back and to be reloaded manually. So they will stop being autonomous, they will stop being unmanned. So I think the new generation of the weapon systems, the lethality packages, should come along to support the new generation of those kind of combat systems. When we start talking about defending against future swarms, then the technologies. I mean, we have to rely on the new technology. The new progress will have to stand on the shoulders of the development which is currently ongoing for manned platforms.
Thanks very much, Commodore Brasseur.
Hey, thank you, General, and thank you, Your Excellency, for the invitation. As you mentioned, I'm Commodore of Task Force 59. Task Force 59 is focused on the maritime, so the waters, securing the waters around the Arabian Peninsula. And so I have a slightly, different perspective, and I'm happy to share that with you. First of all, this is my 4th visit back to Abu Dhabi, and Task Force 59 is just 5 months old. The task force itself is powered on ideas, and we kind of see that throughout the day. And so I'm going to synthesize some of the stuff that was discussed today. So with respect to the maritime, and please keep in mind, we just completed the largest maritime unmanned exercise in the world last week with over 80 drones, 60 nations, all coming together. So I'm speaking from a very near-term experience from last week. So I'm going to kind of share some of that with you as well. For me, it's 2 things, and then a third very, very important thing. First, it's the maritime robotics, above, on, and below the water, right? Dual use, inexpensive, sustainable solutions that help get the data we need to power the machine learning and AI tools to get in the predictive space, to get to the right of problems, to build the pattern of life we need so we can, as I said, get to the right of the problems vice trailing them. Last week we did the world's first digital ocean prototype, which leveraged commercial data and then drones above, on, and below the water to augment that commercial data set, and then brought that all together. We did this in the Gulf of Aqaba, by the way, and we leveraged Jordanian existing infrastructure brought it all together, and then got into the predictive space by using machine learning and AI to kind of sift through all that data and bring it to the user in a usable format that they're not overwhelmed by the data. The discussion this morning about the end user, I am the end user. We are the problem holders. So this notion of bringing everybody together, that's exactly what we're doing across the triple helix: government, academia, industry, and with our partners, UAE and around the region. So maritime robotics, above, on, and below. And then data. Data is so important because it makes the AI models more accurate, more confidence. We talked about trust. You've got to have the data necessary to power those machine learning tools so the AI can be leveraged and give you smart, leading indicators of what's not normal, okay? It's a bit overwhelming, all these sensors coming in. What we're trying to see is what's not normal, so we can take action to interdict that and prevent, malign activity on the seas. And the third, and perhaps the most important, is the human. If this was not more clear, if this was not clear before the exercise, it was very, very clear after the exercise. The technology is there, it's here now. You'll see it on the expo floor. It's here. It's about adoption. It's about adoption and just what the previous panel talked about. It's about humans trusting and adopting. And the only way you build trust is by doing in the operational environment like we did last week, where it's salty, windy, at some time it was bad weather last week, and we found out that the limiting factor was in many cases the human. Mm-hmm. So those three things, I can speak more about that later. I definitely want to come back to the human aspect of this, and I'll just kind of give you a quick quip of the type of people we're looking for. I may date myself here, but do you remember the person in your calculus class that figured out how to use the TI-85 computer? I mean, the TI-85 calculator? We look for, a mix of that person and MacGyver. So, we talked about the younger generation. Some of my junior officers, they don't know who MacGyver is. So I just tell them to YouTube it, and but we want sort of that mix, the ingenuity, but also the rapid adopter.
Mm-hmm. Great. Professor.
Thank you. Excellency. Thank you for the opportunity. Well, talking about robotics, last Friday, we were in an expedition in the Mediterranean with a robot diving to 800 meters. Not only to observe or see, but also to operate. So we were on several sites, including submarine, aircrafts, and vessels. And it is amazing the amount of challenges you have when you're underwater. I mean, you mentioned underwater. Seeing is one thing, but really doing becomes a big challenge. You need hands, you need feedback, tactile feedback on your fingers, so that you bring those contact information the robot is doing in the water, bring them back to someone, human, to make the decision about the next moves. So in addition to robots, there is something really critical, I think, in what challenges we are facing, and this is the interface. Mm-hmm. The interface to the human, and the technology that we are seeing today is bringing something really new and powerful, and this is called haptics. So the combination of haptics with stereo vision allows human to be immersed completely in that environment and interact in real time with a very complex robot that is disassembling, moving, placing, and performing tasks that go much beyond what we are talking about sometimes in terms of just mobility. So there are a lot of promising directions for this connection between haptics and robotics. Well, this connection also is very powerful in other domains, in healthcare, that is performing remote diagnostic. For instance, we experimented with 3D imaging over 10,000 kilometers from one location to another. And these are very important ways of taking medical diagnosis to distant locations where doctors can intervene and find what is the problem, even for remote locations. In remote work, in the future of work, in remote areas and dangerous places, in rescue and search, in all these areas, that interaction is going to be very, very important. And the interface between the machine and the human becomes really a major aspect of those progress in the applications.
Thanks, Professor. And Dr. Senavarande, could you comment on some of these technologies? I know you have a lot of experience with robotics as well. Over to you.
I'm very well, thank you. Thank you very much for giving me this opportunity to be a part of this very distinguished panel. And I'm very pleased to be here. So as we all know, robotics has huge potential, and we've seen some very impressive progress in the recent past, in the last 5-10 years, mainly driven by big data AI. However, I think we are still at the tip of that iceberg. If we ask in our daily lives, how many robots do we see? The answer is very little. We are quite a long way away from the dream of having a robot in every home. So the reason for this is, I think autonomy in the real world is very, very hard. So I think there needs to be still quite a lot of technological breakthroughs before we see the full potential of robotics and unmanned systems realized in our daily lives. Driverless cars are a very good example. I mean, we are nearly there, but not quite. So some of the major challenges in robotics, they have not changed very much in the last 30 or 40 years I have been working in this field. Things like autonomy in any environment, things like human-like perception, universal navigation, universal grasping, manipulation. So all of these, I think, are still very active problems that need to be solved. So I'm going to touch on a couple of ideas. So one of them is this concept of physical intelligence. So if you take your traditional robot and compare that to equivalent biological system, let's say a drone and a bird, or a marine robot and a fish, you can see the big differences in the actual physical structure. So robots are typically, they're hard, they're stiff, and they're sensors, they're actuators, they're computational intelligence, they're all very discrete. Whereas if you take biological systems, that's almost seamless integration between sensing, actuation, the computational intelligence. The bodies are soft, they are compliant. So I think that there's a lot of new breakthroughs that we can see in the short, medium, long term, in material science, in new design methodologies, in new computational paradigms. So I think physical intelligence combined with computational intelligence, that's an area that I would like to highlight and champion. In addition to that, very briefly, I think we've made spectacular progress in recent years in narrow AI, in big data-driven AI. Now, this, of course, has inherent limitations, even though the successes have been absolutely outstanding. So two ideas. I mean, one of them is this hybrid AI. So there's a lot of algorithmic intelligence that we have acquired in robotics, and Osama Khatib is a pioneer in this area over the last 30, 40, 50, 60 years. And combining this algorithmic intelligence with data-driven intelligence, I think that's a good field to also to look out for. And the other thing is using synthetic data for training. So we are hearing a lot of things now about the metaverse, and again, using this kind of virtual environments to train robotic systems. I think that will be another area to look out for. Yeah, thank you very much.
Great, thank you. And a number of you have mentioned the convergence of a couple different technologies and how power generation and land robotics. Likewise, let's develop that idea a little further if we can. And where are the areas of focus from your experience thus far where we need to really concentrate in terms of solving some problems of convergence of different technologies in order to advance our ability to use these autonomous systems? Professor?
Of course. Robotics is really at the intersection of many different fields, from electrical engineering, computer science, to the material and mechanical design. And what we are seeing is an amazing progress with material that are brought to those applications in robotics, in mechatronics integration, in the fabrication methods that are making us capable of building prototypes of robots very quickly. Our students are building, printing robots overnight, and then they are experimenting with those prototypes in the morning. And these are really amazing technologies that are helping integrating all these different components, in addition to bringing the programming and computer science background to the work that is needed. I really very much agree with what we just heard about the digital intelligence and the physical intelligence. Robotics is really about the physical intelligence in that it is interacting with the physical world and changing the physical world to some extent. The digital intelligence is the backbone to making those machines working. So you need really this integration of the AI-driven techniques with robotic physical systems to produce those results. So there is very much of integration.
Thank you. I noticed, Commodore, I see you coming out of your seat there. You wanted to comment on something that the professor said.
Well, first of all, thanks for putting me on the stage with 3 PhDs. This is very exciting to be up here. Just, I wanted to come back to the professor's first point about the user interface, where all this convergence meets the end user. And I wanted to share with what happened with you with the DigitalOcean prototype. So again, as I mentioned, we had all these immense data sets coming together to sift through the pattern of life data and pull out what was abnormal. Well, you would find that there's just a few things that are abnormal. And where we were operating out of the Jordanian Naval Operations Center, and it's full of, like 12 screens with, just bunches of blips on them. But the user interface powered by AI was kind of blank. And they're like, hey, what's going on here? This is not what we're expecting. And that's the whole purpose of it, is to highlight what's abnormal so you can sift through the data. So the convergence of all these sort of supporting technologies is very, very important. But that connection between the end user is the most important, because if that connection is not there, they won't use the tool. And you may have the best technology, but it'll be on this side.
Right. Absolutely.
Doctor, you mentioned power generation, and it's important for land autonomous systems on land and robotics. Could you expand on that a little bit?
It's important everywhere, anywhere in the new time to come, the power generation, and where we are heading now. There are some technologies which are there for other domains. For example, an underwater domain, which are looking very promising, but not yet applicable to the, let's say, land domain platforms. And there has to be a huge additional effort in a basic science to get us to that what they call energy density on a proper level that could be applied on a ground platform, let alone on the aerial platforms. But it's a hugely interesting area, and when we think of this, there is a great number of technologies that we need to look into. But then again, we are sitting standing on the shoulders of more than 30 years of high-tech work throughout the defense community, and I think that again, my impression is that we will now it's me looking in a crystal ball and predicting future, that will at least some like 5 to 10 years from now, we'll be using these novel technologies to implement and make work the ideas, military ideas, which are there for some time now. The technology was not there yet. Yeah.
And you also, if I could follow up, you also mentioned lethality and the concerns. Are there any unique aspects to lethality that are affected by artificial intelligence or autonomous vehicles that you've seen?
I believe we'll be talking about this a little bit on what is the AI is irreplaceable to control all of that and to make that joint robotic human battlefield in the future. And the man-machine interfaces both on the highest command level to the lowest level. Then there are some very interesting things which are currently going on. But lethality again, we are pretty much focused on what are the progresses in the lethality for the ongoing programs that will migrate to the robotic platforms for sure. And of course, as we had the pleasure of hearing the general here, who has a task of dealing against all of this revolution coming at us. And I think that there needs to be some dramatic progresses in how we're going to defend our, let's say, ground platforms against all of those swarms of robots coming at us.
Right.
And again, I think that there are some very, at least we in Serbian military, we are trying to deploy now an air defense system which will be capable of dealing with some sort of swarms of today with some not very expensive. That's the math. If you apply a very high tech and very highly expensive effector against something which is $200, basically you are it's economically unviable. So for the time being, there is a potential to use the existing technologies with a little bit improvement of their lethality to deal with the looming threat which is at hand. Of course, that will have to migrate also on the platforms itself, and there will have to be something like additional to the air defense layer that we'll put on top of our land forces. There will have to be some kind of individual protection of a platform itself. Yeah. And then again, technologies are there to active protection systems, which are now applied on a tank, are pretty much capable, and they are designed to deal with a much harder target to detect and defeat. A little bit they are now oriented horizontally, not looking upwards, because this is where the threat will come, as we have seen in the recent wars. But it's not that technically, in my opinion, difficult to add this additional layer. But when a time in a near future we'll need to deal with something like EMPs or effectors that will be capable of defeating multiple drones, multiple targets simultaneously. If you try to shoot them down one by one, for example, like with a laser, you're doomed because they will overwhelm you with numbers. So those technologies are I think, there to be observed. And they, I think, could be available for defenders pretty soon.
Right. Thank you. Both of you have worked with robotics in the maritime domain. And can you share with us any unique aspects or lessons you've learned with operating robotics at depth or in a very complex environment, Mike, with multiple navies and interoperating? So could you each please expand on that a little bit?
So depth and water are very challenging to mechanics and electronics and every aspect of this. And I mean, we know how to handle all of these challenges for vehicles. But when it comes to robots that has arms and fingers and head and all kind of additional functionalities, it becomes really hard. Because if you have arms, then you have to oil fill your arm so that you can have the same pressure inside that equal to the pressure outside. And when you go to 1,000 meters, this is huge. The pressure is huge. So huge, but it is equal on the material, and you manage it. The problem is hands, fingers, arms has sensors, have electronics. And that electronics is going to be affected by the same pressure. So now you have to redesign your electronics, your component to handle high pressure. And in fact, we went from 200 meters to 1,000 meters, and we had to do a lot of redesign, solid state instead of the normal oscillators that are being used. We had to do a lot of work on just the component that are needed to operate your robot. Then comes the challenge of experimentations. You mentioned the weather. I mean, this is really a big challenge. We were in the Mediterranean, in Corsica and France, Toulon, and last week, and we had really bad weather. Ultimately, we moved to the east near Cannes. You know, the film festival in Cannes. And that's where our robot broke the record. So I told the crew that Ocean One, the name of our robot, Ocean One came to Cannes and recover treasures and came back with the golden palm.
I'll just add on a few comments with respect to the professor. You know, again, I grew up on an island. I love the ocean, and you know, I'm most comfortable in the ocean. Robots are not necessarily most comfortable in the ocean. You know, a lot of the technologies we're using are, you know, originated in the land space, but don't quite make the transition very well in the maritime. As I mentioned, it's salty, it's windy, it's not ideal for electronics. In the below the water space, you know, it's very hard to communicate below the water. And you have one of the world's leaders here in underwater communications with Najwa at TII. You know, she knows how hard that is, and she's working to power through that. The other thing is, you know, they're machines at sea. You know, I was captain of an LCS. It's hard to keep a ship at sea manned, you know, with all the machinery going on in there. And, you know, one of our providers for this exercise has actually got a sailboat, you know, that's powered by wind and solar to kind of, you know, power through that, you know, that very hard problem of keeping a machine at sea for an extended period of time. You know, and that particular sailboat has sensors on it, you know, atmospheric, but also a camera, and it's powered by machine learning. It's a really powerful tool, and you just got to get through the basic thing of sustaining something at sea for a long time. And then the final point, and this is actually the most important point, because it's about partners, right? And that's the only way you scale. The ocean is massive. It covers 70% of our planet. You know, no one nation can bring together the assets to really protect our seas. And, you know, and if you want to go into the climate space, you know, the ocean holds the keys to solving the climate problem. So it's a matter of making the robots interoperable with your friends and allies and bringing all that information together, and then leveraging the data, again, to get to the right of problems, but also to understand our oceans, which we really don't fully understand. I'm sorry to taking it back to the sea, but, you know, happy to do that since I grew up on an island.
Professor, did you want to add anything to this conversation? You had mentioned previously the human robotic interface as it affects us, but please jump in here.
Yes, thank you very much. I think the robotics is the classic transdisciplinary science. So I think this convergence of these different technologies, from the sensing to the intelligence to the materials to the design to the edge computing, I think that's got a key role to play in developing future intelligent systems. And in addition to that, the tight integration of these technologies in one body, I think that again is a key feature of robotics. So the synergistic integration, bringing in technologies from different disciplines at the right time. So I think that's my sort of a contribution on the
Thank you.
On the integration side. Thank you.
Thank you, Professor. I'd like to shift now to ethics and questions of ethics in the remaining 10 minutes that we have. We've discussed a couple of times here about the ethics of use of lethality, and it reduces risk to humans, so it reduces risk to your own forces, so that's ethical. In that sense, you're protecting the lives of your own forces by using robotics, so there's an ethical justification for using this technology. There's also the ability to protect your own population, your own infrastructure, your own economy through the use of these capabilities, so that has an inherent ethical dimension to it that makes it ethical to pursue these technologies. Where we get into challenges is perhaps autonomous decisions over the use of lethal force. So if we decide to program to do machine learning, to train the AI as best we can, to then make decisions about the use of lethal force, this theoretically is one of the areas where we could get into ethical issues if it doesn't apply that lethal force properly, if innocent people are killed. On the other hand, if you are risk averse in this area and a swarm of enemy weapon systems get through your defenses because you've been hypersensitive to this, then you in fact have endangered your own population and your own infrastructure. So it's a tough question on what is enough and how best to do this. And of course, having a person in the loop has been the way we've done it thus far, but we haven't been faced with swarms. We haven't been faced with these kinds of attacks previously. And the systems that make that possible, satellite connectivity, GPS, all those are potentially at risk in the future. So having an autonomous decision-making capability inside a robot or another system could help defend your critical assets, your population, in a better way. So again, a very complex picture on the ethics of this, and I know you each have thought about this in different ways, and I'd ask you to sort of comment on that, things that we should be thinking about as we go forward. Doctor?
Well, that's tricky.
Yeah.
And from my opinion, well, the current regulation is there, and I believe it says they have to be built autonomous systems. They have to be built with the possibility for for appropriate a level of human judgment before applying lethal force.
Right.
Now that is okay with the how should I say, man in the loop systems, but with the when the system of systems start to mature more with their autonomy, and what they lead something like a level 8 or 9 or 10, how they are graded now, that equation is going to be extremely tricky. And obviously the human operator or the commander or so on and so forth will be with quite a lot of dilemmas of how to, and they will be a blocking point. And if we take and envision the how should I say, global lethality battle management systems that will be influenced by or tailored by artificial intelligence that will collect all the global data from all of the sensors and then apply a command for a howitzer to shoot or from a submarine to shoot from thousands of miles away. If there is a glitch, there could be a catastrophic how should I say, outcome. I think again looking at the crystal ball of time, which is very tricky. Probably we don't need to worry about the artificial intelligence implemented as we are going to implement it, both on our lowest level to the highest level of commanding our forces. Obviously, it will move the men from the loop a bit, and a number of people that we will have there to, how should I say, make any kind of, with any kind of, how should I say, enhanced reality vision so that they can do any kind of click on a particular target. That I don't think that will work in this equation. So, and then again, we as humans, and traditionally when the danger is near, then the question of ethics are becoming very, very tricky. And we better not learn. We better not learn the AI and machine learning to learn these characteristics of ours. Then we can become a loser on ethics when we are endangered, because then we will. In the following steps, we will be very much endangered. Right. So I think that this, let's say again, probably from 20 to 30 in catastrophic scenarios and artificial intelligence taking on us with our own tools. I believe that probably something like 20, 30 years from now, we shouldn't be worried that much. We will be able to somehow reasonably control that and not to get the lethal effects where they were not supposed to be, probably. After that, I think that we should start looking for John Connor and start to training to mount an insurgency against machines.
Thanks very much. Please, Mike.
Well, this is a really, really tough situation and a tough thing to discuss. And I want to take it kind of from the macro level all the way down to Michael Brasser, On the macro, so we had a discussion last week and Najwa and Deep were on this panel, and one of our panelists, Amir Hussein, said that the OODA loop is collapsing before our very eyes, okay? So right now the human is on the loop, but as you project forward, the OODA loop is collapsing. Well, that's a statement by Amir, not by me. You can decide if that's true. This brings up the question that you're asking. And from the DoD's perspective, we just published the ethical use of AI. And I'm just gonna state the areas that it's focused on. Number 1, responsible. Number 2, equitable. Number 3, traceable. 4, reliable, and governable. Okay, so those are kind of the 5 aspects of that. From the Task Force 5.9 level, when I was building my team, it's one of the first people I looked to add to my team was someone with expertise in ethics. And I got a world leader on my team, Dr. Meryl Eckelhoff. She's Dutch MOD, but working now at the Joint Artificial Intelligence Center, just to help navigate these areas. Obviously, you got the overarching principles, and then right here on the leading edge where the tech and the AI meets the real world. And so I'm leveraging that experience. We also have lawyers on the staff, and then just kind of finally to Michael Brasser speaking here. We at the end of the day, we're defending our values. And if you acquiesce to your values, if you give up your values, and then what are you really protecting? So that's just kind of me saying that. But from the DoD down to Task Force 5.9, that's our perspective. And what I had to get another PhD on my staff to help figure it out, because it's real tough to navigate.
Thanks, Mike. I'd have one point on that. The legitimacy, using ethical considerations and how we apply force sustains the legitimacy of what we're doing, which is critical in terms of our ability to have freedom of action and continue to operate. Because if we act in an illegitimate manner, then we're going to lose our freedom of action, and we should. So thanks for bringing that. Professor, over to you. We've got about 2 minutes left. I apologize, but a minute each for both of you.
But more broadly, robotics brought a lot of questions about the social impact, safety, and all these ethical issues. The community has been conducting a lot of discussions, meetings, special conferences, discussing those issues. In the 80s, we had industrial robotics, where robots were taking the place of workers. And that was a big challenge, because that transformation during the automation process was really hard on the workforce. Now the new robotics, the robotics in the field, the robotics in the real world, is bringing human and robot together, closer together.
Right.
Safety becomes much more challenging because we still have a remnant of these very bulky and tough robots. So today we are building new kind of robots that are compliant, lighter, safer, but still there are a lot of challenges from that point of view. So these ethical issues goes over many different aspects, from the safety to their impact on society and how we deal with the workforce.
Thanks, Professor. And Professor Severante, you get the final word, 30 seconds.
Thank you very much. Two things very briefly. I think one is raising awareness. I think it's really important that we build in ethics into our educational programs in robotics. At Khalifa University, we are initiating BSc in robotics and MSc in robotics, and it will be mandatory for students to study ethics. So that's number one. And number two, I think it's really important for us to get this one right, because public acceptance of this technology will very much depend on how we get this right. So having the right regulatory frameworks and international consensus, I think is really absolutely critical going forward. Thank you very much.
Thank you, and thanks to all of our panel members for joining us today. Please join me in a round of applause. Thanks.